And welcome back. Now today we're going to talk about a little device that I've had in my box for absolutely months and months and months, and it's this little device down here, and that is a TM1637. So it's a quad LED display. It's a bit like having 4 of these, and the reason why I'm doing this video is because, well, somebody on the YouTube channel asked a question, or at least made a comment about a video I did absolutely ages ago. Well, it was number 43, so you can tell how long ago that was. In fact, let's have a look at that, the comment, because it's worthwhile. It was a very good comment, and then we'll find out why I'm doing this video. So this is the comment that Gavin made, talking about the LED multiplexing video I did, number 43, and it was basically, it was a, well, how does multiplexing work on a 7-segment LED? After all, if you've got one of these, how do we save current by multiplexing? That is, highlighting each segment one by one on here, so we don't draw current for every single segment, and therefore, well, A, use up lots of current, and B, burn out our poor little Arduino. So the answer was that we multiplex, that is, we switch on and off very quickly. Now what Gavin has said, he says, hang on a minute, yeah, okay, I can understand what you're doing with each one of these little segments. Let's use my pointer. So each one of these little segments now is being switched on and off very, very rapidly, but all the current flowing through all these common anode or common cathode LEDs is still going to a single pin on your Arduino in that demo. And yes, I had to admit that was the case for the demo. That's exactly what's happened, because I didn't want to put a transistor in. At least that's my excuse for not doing it here anyway. And it was in fact the real reason. You certainly wouldn't design it like that going forward. So yes, Gavin was correct. You do need a transistor so that each individual LED, so all these little segments, are connected at one end all together on one of these pins, whichever one it is, and that pin is then switched on or off by the Arduino extremely quickly, hundreds of times a second, otherwise you'd see flicker. Anyway, if you want to know more about that, the wheres and wherefores of multiplexing and how it all hangs together, do have a look at video 43. Because I do demo that, in sort of slow motion, so you can see exactly what's happening and how, when you speed things up, it just looks like, well, like this one down here, really. However, the point I made in the video itself was that faffing about with all these LEDs, and you'd need 8 lines, even though they're shared between multiples of these, so you could have 4 of these all queued up, and you still only need 8 wires from the Arduino, plus then 4 more for each of the LEDs to switch on and off. I hope you're following this. I said, look, this is all right in theory and how it works, but it's all too much faffing about, really. Well, would be for me. I would never use an LED like that. I said, what we really need is a TM1637, and I'll do the video as soon as it comes through the post. Well, that's from that slow boat from China. Except I forgot. So it's been sitting in my box, this little thing here, for, well, months. And it's only because Gavin's prompt, really, or question on that made me think, where is that video? Oh my goodness, I haven't done it. So, back to the drawing board then. Assuming that you've now watched 43, or you understand how multiplexing works, this is a TM1637. Now you can see it's 4 LEDs in one unit. Let me just unstick it from the board there. Fairly small. Not a lot to say about it, really. There's a little TM1637 driver. The best bit about it, if you remember, I just mentioned that you would need 8 wires to drive, well, even one of these, but whether you had 1 or 4, you still need 8 channels from your Arduino, which is, well, let's face it, far too many, isn't it? And it's just pointless doing it like that. This one needs 2. As you can see, we've got 2 for power, but they're not, they're not considered channels, are they? It's just power. It doesn't have to be power from the Arduino. It can be power from any 5-volt supply. And then we just need 2, these orange and yellow ones, to actually drive the information. Now what I've actually got running on here is the demo program that comes with the library that I'm using for this, because I thought, well, all right, let's not faff about, and I've just enhanced it a little bit. If you watch this cycling through, it'll start displaying some letters soon, A, B, C and so on, and that's the bit I just tried out to make sure that I understood exactly how the library was working. There it goes, E, F, and done. Great, so it works. Okay, now this particular model, if you notice, if you look very close, I'll bring it closer to the camera, doesn't have a decimal point in each of the LEDs. Normally you have it in the bottom right hand corner, but what it does have is this colon here in the middle, because these are designed for clock modules for displaying the time. Great. Now actually I'm just using this little bit of red cellophane there, or acetate sheet it is. It's easy to find on eBay. It's for lighting purposes, for theatre. You get them in sort of A4 sheets, this size of this mat, for about, I don't know, a couple of quid if that, and you can just cut them up and use them in front of LEDs like this. And I know I've said it before, and I apologise for all those viewers who have heard me say it too many times now. What you're seeing here is a very white light, is it not, with a sort of a red halo effect. In real life, these are not white. They are beautiful ruby red. Even without this filter on, this is ruby red and very nice, but you put this filter on and it really does make it nice. Think of your bedside alarm clock, assuming that you've got LEDs, not LCD, which is a bit different, but LEDs there also will have a red, assuming your LEDs are red, a red filter in front of it, just to give it that contrast. So that's why this is on here. But as I say, you won't, these white numbers, you don't get that in real life. Right, I'm not saying it again, ever. Well, not until the next time the video comes up. Okay, so here we have then this sort of 4-digit, obviously designed for a clock. But of course you can write certain letters on here, well up to four letters for a word. Obviously any numbers. And I thought, well, if you were to include this into an Arduino project, because it's very, very cheap, this. We'll have a look on the internet in just a minute. You could, add value at virtually no cost. 2 wires, a library, this unit, which would fit rather nicely in the front panel, and you've sort of added value at a stroke. And more to the point, it shows others, if you like, if you're interested in that sort of thing, it shows others that, you can display stuff. And, I don't know, people, when they look at projects, they like stuff with lights on. I've noticed that a lot, LEDs, anything. My little coffee cup coaster at work, which is still in use daily, I might add. Look for the video with coffee cup coaster. That's got a little LED in it, flashes red to let me know that there's no coffee left, and yellow when there is coffee in there getting cold to tell me to drink it up. And people are fascinated by that. They go, oh, what's going on there? It draws them in, doesn't it? So if you could add something like this into your project, and all it requires is a little tiny, oblong cutout, and it's got 4 mounting screws on it. It could add something to a project as well as displaying some valuable information, maybe the temperature or an error code or I don't know, a word or two, whatever. I'm here to tell you though about the TM1637 and how easy it is to add it into an Arduino. Right, the sketch and the library I'm using is virtually unchanged, as I say, because I just wanted to get it up and running and to bring it to your attention. So the sketch, let's go over to the code window. Here it is. And before you ask, yes, I'm using the Eclipse IDE for this, but I won't be in a minute, so bear with me. I like using the Eclipse because when you hover over certain words, it displays what it means. So when I hover over this word display, for example, I get a little tooltip that comes up and says what it is. Now you can't see that, unfortunately. There's something about the window capture process that just doesn't let that happen. However, if I show you my monitor rather than capturing a window itself, so this is the actual code, and watch what happens now then when I hover over display. You see that? It tells me what kind of object it is. And if I hover over something like data, you think, what's data again? There it is, look. So you went 18, it's data and it contains this. What else? If we said here, oh, look, here's an object, gives me the whole class here. Look, and if I press F2, excuse me, why go over there? Right. So I've now got the focus on here. You can make this window bigger, and well, scroll up and down and read all about it. Now this is brilliant for debugging stuff because you can tell what it is you're actually trying to run just by hovering over things. All right. So you know you're deep in the bowels of the program. You think. What display dot, what set brightness, what am I supposed to supply there? Oh yes, it's a uint8t, otherwise known as a short integer. No, it's not a short integer, it's a byte actually. Brightness and the boolean on. Great. So then you know immediately, and it just speeds up the development without having to constantly refer back or guess and get it wrong. So that's the Eclipse IDE, and jolly good it is too, but as I say, not for the faint-hearted. If you don't use a decent IDE already, you might find it hard work to install, but have a go. I'll put some links at the bottom of this video, right, for this IDE, because I think it really is worthwhile, and you may even think it's worth the $5 a month as well. Right, so this is the demo program, and so I've just added a little bit down the bottom here. Where is it? Down here, to display ABCDEF on the various digits, and what it allows you to do. Let me pick this off again, pick up my little pointer. So what it allows you to do is to say either display a value starting from digit 0, 1, 2, 3, and you tell it how long you want it to be, or you say I want it starting from this digit or this digit. Do I want it 0 filled at the front or not? And as you saw with the letters, when you say I want to write something to this first digit, it won't destroy what's already on these other three. Not unless you say, actually I'm writing something to here and it's 4 digits long, but you don't display anything or give the data for these three, in which case it will of course then blank those out. As you can see here, look, it's building up, you know, different length digits. It's very flexible library to use for that. Now the library I'm using here, we go back to the code window, the library I'm using is, let's go right to the top, I'll put a link in for this as well. This is the TM1637 display library, and as I say, it's pretty good, and it lets you do all sorts of things. However, I didn't use this in my final design, and for reasons that will become apparent. So let's think about now a little bit more about what else we can do with this display. Now the obvious thing to turn this into, of course, is a proper clock like this one here. Is it easy to do that? Well, let's have a think. If you're going to put this onto an Arduino, which is doing something else, and this just happens to be a sort of a side issue thing for displaying, you know, error codes or small little words or whatever, and you just happen to want to display a clock like this as well, well, let's see, how easy is that going to be? You could, but I wouldn't recommend it. Just trying to keep the clock running like this from an Arduino, just counting up the millis and sort of giving a rough approximation, because that's all it would be at the end of the day. You could, of course, connect a real-time clock to it, a DS3231, for example, which I've done a video on. There it is on screen, look. Which one was better? And of course, we decided that the 31 was a lot more accurate and cheap. So for a very small outlay, you could connect up a real-time clock to this and have it display the time in this sort of manner. Except there's downsides to that, isn't there? If you watch the video on the DS3231, you'll see that to actually get the time on that unit set up can be fiddly, because you've got to set it initially, and you can't do that within the code because it's always going to be wrong, isn't it? So you have to have some sort of mechanism by which you can set the date and time and get the time out of it. And that's once set, don't get me wrong, it's a fantastic unit and it's really, really accurate. So once you've set it, it's set. So what's the alternative? Well, frankly, I've done a video about this as well, all about getting the time from the internet. Now you might be forgiven in thinking that grabbing the time from the internet is a trivial affair. After all, once you're connected to your home Wi-Fi or whatever, it doesn't have to be Wi-Fi, it can be Ethernet. Grabbing the time is surely child's play. Well, if you use the proper library, and the examples out there, and everybody seems to use exactly the same code. Yeah, sort of trivial. In this instance, not quite as trivial as I would have liked, because the eagle-eyed amongst you may have spotted that the Arduino Uno that this was all connected to, this one here, has been disconnected now, and I've connected the same sketch, pretty much, onto an EspDuino. So this is an ESP 8266-13E module on this board, and that's all it is. It hasn't got an Uno on it at all. So it's totally ESP'd, if you like, and very easy it is to do. We've done a few videos on ESP type modules in the past, and indeed I've done a whole video on getting the time from a network time server using network time protocol. That's NTP. Basically, you query servers in a location near you, geographically near you, using a special a special protocol really. You send it down 48 bytes, it sends you back the date time, sometimes, most often than not, but often it won't send you anything, or won't send you anything in time. And these servers are in fact run around the world pretty much by volunteers, would you believe? They dedicate their servers, or allow their servers, to be used as time servers, which is perhaps where the problem arises. If you're issued, a bit like DHCP, you go to the NTP pool of servers and you say, give me a server near me, and it works out where there's a time server, and it says, here, I'll use this address. And of course you query that server for a time, and maybe that server isn't running today, or has had a bit of a problem, so it doesn't reply. The next time you do it, you might get a different address, and then you do get a reply. So it's all a bit hit and miss, really. More hit than miss, I must admit. I mean, it works well when it works, but quite often you don't get a reply. Let's just have a very brief look at the code. So we'll shut down the previous code I was running just to display some numbers on here. And we'll have a look at the, well, new code, which is not new, it's from a previous video, but we'll see how it looks. So here we have the code, and as you can see, I'm back into the Arduino IDE now. As you can see, this code here is pretty simple. Now, you may see a line at the top here where it says include NTP clock 2. Now what that actually contains, as you can see from this tab up here, is in fact the code from the previous videos where we use the ESP, whether it's this module here or any kind of ESP, to go and get the time from a network time server. So I'm not even really bothered about that. I mean, I'll show it to you in a second, but that's not what we're here for. What we're using that for is to say, fine, go and get me the time, and then all we're doing in here is to say, okay, that's debugging, that displays something into the serial monitor or debug window, and here we're just literally printing out to this module here the time, and then a little delay, because as it says here, we don't need to do this very often, but if you wanted it non-blocking, take that out and do other stuff. Now the library we're using here is this one here. It's the 7-segment TM1637, which was different to the one we were using before, because this one works really well for clock displays, as you can see. You can tell it whether to blink the colon, as I've got it here. You can tell it whether you want zero-filled minutes and hours and things, and it's just, well, it's having added an include for the library. We then create the actual object using the 2 GPIO pins that you're going to use for this device. Remember, it only uses 2, a clock and a data. And on the EspDuino, I'm using pins 0 and 2 because they're the first 2 available. And in the loop, well, it's just this one line, clock.printtime, and it uses hour first, then minutes, and then true, meaning do you want to blink the colon in the middle. Now, I have hacked that bit of the code, because what it did, in fact, was just flash this little colon in the middle here very, very quickly. Oh, look, there's the debug window come up. We'll talk about that in a minute. Let me just get rid of that for the time being. So it was flashing this colon extremely quickly, almost like a flicker for about 300 milliseconds. I thought, no. And it was blocking as well. It actually delayed, so it showed the colon, waited for a bit, took it off, a bit like the blink LED that everybody writes as their very first Arduino sketch. So I've changed it. Now you notice that occasionally it sticks on or sticks off for a second or two. Look, see it's sticking now? Now that's because this isn't going away to the NTP server saying go and get me the time. And that in itself can sometimes take a little while to actually either send the request or to wait for a reply. Now I only wait for about 500 milliseconds, so that is also blocking, but I just felt it was too much work really for me to play about and make that bit non-blocking. But certainly the blinking of the colon is easy to do. Now whereas we're seeing this occasionally freezing, the colon, as I say, sticks on or sticks off, that's because, let's go back to the debug window now. As you can see here, I'm getting the value from this UK pool. I'm saying give me a server please, and it goes away and gives me a server. That's the first delay. Then I have to query that server and say give me the time please. So all that adds a bit of time. What would really happen in real life, you wouldn't go to an NTP server and say give me the time every 10 seconds, which is what this is doing. In fact, it seems to have stopped at the moment. Let me just kill that window and open it up again. Right, okay, this is the debug window, and what it's showing you here is that it's sending a request every 10 seconds. Look, that one, you see, says no response, and then does a few time displays, and then 10 seconds later, after this one here, it has another request, and so it goes on. Every 10 seconds it's sending a request to the NTP server, and as I say, at the moment it's being a bit, well, unhelpful, because you're just not getting back these responses that I'd expect to get back, and in fact has come back, obviously. Perhaps it's because I'm sending too many and they've blacklisted me or something, I don't know. Oh, there we are, we got one back now, so it's synchronized again. But in real life you wouldn't do it every 10 seconds or anything like that. You could do it once an hour, or maybe, you know, 2 or 3 times a day if you wanted this clock to stay absolutely in sync. So, I mean, at the moment, as you can see, it's playing quite nice. And what would happen is, if we're not requesting that time for an NTP server every 10 seconds, this colon wouldn't freeze like it does. The other thing that you'd probably do is request a server from the pool, and once you've got a response like we have now from this one here, remember that IP address or the name or whatever it's giving back, probably an IP address, but I don't know, whatever it's giving you back, remember that and just continue to use that for the full 24 hours. But as I say, if you're only querying it 2 or 3 times a day, it almost doesn't matter. What does matter, of course, like here now, see there's no response here. Well, if that was the time you were requesting it at, say, midday and you didn't get a response, well, that means you've probably got to wait another 6 hours, doesn't it? So you'd have to have some logic in your program to say, I've requested the time, did I get a response? Yes, I did, fine, we don't need to do that now for another 6 hours or whatever, 12 hours even. And if you didn't get a response, you say, fine, I'll try again in another minute or 10 minutes or something until it does synchronize. But for demo purposes and demo purposes only, I'm doing it every 10 seconds. And as you can see, look, it's stuck. So you see the delay there? That was quite a big delay. So whether it's network delay or NTP .org's delay, who knows? But during that delay, this colon will freeze. As I say, not normally a problem, but just so you know. Okay, so the code then, we've said this bit of code is so simple. What is there in the NTP clock 2 then that we grabbed from the previous NTP sketch that we did a little while ago? Well, let's have a look. So here it is, grabbed in its entirety from when we did it last time. We're still using the time library as well. That's the thing that keeps this clock running when we're not requesting stuff from NTP. It just says go and get me the time please from a server that I'm telling you to get it, and off it goes, grabs a request from UDP, so this is all being sent by UDP. If you want to know about all that, go and have a look at the other video. And well, I've got some debugging messages here, or this might be part of the original code from the library. Here's my delay. Now I've been playing about with that delay, whether it's 100 milliseconds or 1 second doesn't seem to make an awful lot of difference to whether or not we get a response. Like this here, no response again. Here, look at the big delay while we're waiting for a response, and still no response. So I don't know. Now, in fact, when I was playing about with this initially, I couldn't get uk.pool.ntp.org to respond at all. It just said no, no, no. So I tried the American version, which I think might be in the comments. Let's have a look. Does it? Oh yes, here it is. Look. So it says in the American version, use time.nist.gov. Well, I used that, which is probably the worst address I could use, being in Europe. But there are some Europe ones as well. So instead of this UK pool, I think there's a europe0.pool.ntp.org, and I've tried those, and they seem to respond pretty well actually. So whether it's just the UK bit that isn't working as well as it might be, don't know. But we're not really bothered about that, are we? Because all we're doing is grabbing the time via this original sketch and displaying it on our little unit here. Now, if we're displaying that as a sort of side issue as part of our Arduino sketch, the ESP8266 can be doing lots of other stuff. And remember, this is a really powerful board. It's got loads of memory, 4 mega memory, and I can't remember how much RAM it's got, but it's got loads. And you wouldn't run out of room on that. What you will run out of are those pins. It hasn't got very many pins compared to an Arduino Uno, that is. So you're a little bit limited. I think there's probably about 10 on there. And it's only got one single analog pin. Okay, so that also might be a deal breaker for you. But if that's the case, then what you could use is the ESP module, which you can buy separately and add to your Arduino project. Seems a bit of a waste just to use that for Wi-Fi, but well, you can do it. Or, of course, you can use the Ethernet shield or a Wi-Fi shield that just plugs on top of a standard Uno like this. Just literally just plugs on top, and it gives you Ethernet or wireless capability. So that's another way of doing it if you want to get the time. Right. Oh, look, colon stopped again, obviously grabbing the time from somewhere. That will change over to 7, and I think that probably indicates time we were leaving. Before we do that, let's just have a look at the browser to see how much these ESP units were. Right, here we are from AliExpress. I just had a quick look to see how much they were. This is probably about the cheapest I can get with the shipping. So that's 701 with a few pence of shipping. What was this one? So that's 548, but it's 166, and I'm afraid my mental maths isn't good enough to work out if that's more expensive than this one here. This little unit then, the TM1637, that's the crux of the matter. How much is that? Well, let's have a look at that one next. Right, here we are now. Prepare yourself, because these are really expensive, as you can see. 55 pence, which is probably what, I don't know, 70 cents in the United States. They are cheap. Oh look, there's a green one there as well, so you don't have to get red. And that's 67. Oh, we've got to pay shipping on that. So that's just £1 then, which is what, $1.30, I believe, these days. So they're cheap. So this is what I mean about adding it in as almost an incidental as part of your Arduino project. You don't really want to build something like this just to get the time. For that, you might as well go down to your local supermarket and pick up a really cheap bedside clock, because you can probably get one of those for about £5. But if you just got an Arduino project and you want to add a little bit of pizzazz, whether it's displaying the time as when it's in standby, but otherwise perhaps displaying something else, a counter, or even the temperature, you could do that for next to nothing. Once you've got a display like this, then well, it's a nice, useful little thing, and far easier than trying to get 4 of these all wired up, with 8 wires. Now, of course, I have done other videos on using something like a µController. It's this one here, but there's far too many digits on there for the time. And of course, you could use an LCD like this as well. This is a 16:2. That's I2C control, because you've got this little backpack on the back. They're pretty cheap as well, frankly. But as I hadn't done this video for the TM1637, and having spotted I hadn't done it and found this in my box, that's why I thought, right, let's put an end to this. There it is. I hope you found it useful. Plenty of other videos to watch as well. So, hope you found it useful, and thanks for watching. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.